All right, so welcome to the today's version of the AI Developers Meetup here at MLCon. Nice that so many of you turned out here after grueling days of conference, still at 7 p.m. My name is Nico. I'm a MLOps / AI engineer at the Applied AI Institute that you see down there. We do lots of things primarily in the open source domain around AI, such as projects, developing them out in the open, but also meetups like these, simply because we want to get an idea of what stories are there to tell about what people are doing in AI, what challenges they overcome in their daily work, in their side projects, and also, of course, to create a space to connect with people, to network, which some of you have already done here before the kickoff. And with that, we can probably already get started. We have 3 exciting talks today. And after that, we will have a networking session. It's a standard format, like you see with lots of meetups. I'm sure you also saw the pizza in the back, or you smelled it. So that's also available if you like. And the talks themselves will be about 20-25 minutes in length, including a Q&A session afterwards. And with that, I would kick it off to Julian from SenseWork.
Okay, you can hear me, right? Okay, good. Okay. Awesome. So, hello everybody. My name is Julian. I am an AI application engineer at SenseWork, and today I will be talking about Neuralyze next level vision AI. Now, before delving deep into the concept of what Neuralyze is, I would like to start with a question. So, what is machine vision? So if you didn't hear, or if you heard about machine vision, or if you have kind of an idea what it actually is, I would like you to raise your hands. Okay? Okay, that's pretty good. Better than expected, actually. So for the, let's say, other half that they don't know what machine vision actually is, I will just tell briefly about it. So before starting my journey at SenseWork, I also didn't know what machine vision is. I know what computer vision is, and I guess also most of you, computer vision is pretty familiar concept. But I knew it had somehow to do with computer vision. And to some extent, that is true. It is similar to computer vision, but it's a bit different. So when you think about machine vision, you have to think about the word machine itself. And it has to do with the machinery. So in general, it inspects and analyzes and processes visual information, so images. But this is done typically in industrial manufacturing. So with machine vision, we care a lot about robustness and real-time processing. So it has to be extremely quick. And most of the time is constrained. And it also works with systems that integrate cameras, lighting, sensors, and processing units. So it's an extremely crucial step when you acquire images, because if your images are garbage, then your model, of course, will spit out garbage. We already know this. Now, for computer vision is just let's say, the part or the area that focuses on understanding what's in the image. So it's pretty easy. So we at Sensor focus on both machine vision and computer vision, but in general, vision AI. Okay. So now that we know a bit the difference or what we focus on, I will just talk about the challenges, the AI development with Neuralyze, and finally some application examples. Actually one, because I think the time it's a bit tight. So let's start with the challenges. So with classical AI model development process, why do projects fail? So all the time we hear about disruptive technology, groundbreaking technology, new ideas, which of course they work partially, but also a hot topic there is right now, as an example, it's for instance AI agents. Everybody's talking about them, but then when you put them into production, you start having problems, so they don't work. So why do projects fail? And in this case, I'm talking about vision AI rather than LLMs or Gen AI and whatever. So sometimes you lack heterogeneous tools and interfaces. So when working in a team, most of the time you don't have similar tools, and this slows down the whole process. Then you have non-standardized data and labels. So when talking, for instance, about object detection, right? If you have worked with YOLO, you need specific coordinates or a specific format for that architecture. But then when you switch to that architecture from another one, then things start getting a bit difficult. So you need a standardized way to save labels and to annotate data. And then you have manual annotation. So I had quite some painful experience with manual annotation, so I had to label a lot of data as an intern. So I guess you already know how painful it is, and it's extremely time-consuming and, of course, expensive. Whenever also you do, for instance, semantic segmentation that you have to label every pixel, don't get me started with that. Then you have lack of transparency and lack of traceability. I would prefer lack of traceability, because when you train different models, so for instance, you start with a version of your data set, you train a model, you get results, you have the first iteration. Then you have to train another one. Maybe you add some more data, maybe you delete some data, and then it gets pretty complicated pretty quickly, because you don't know anymore which model performs better than the other, or vice versa. And this, of course, slows down the whole process. Then you have integration barriers, so it's quite difficult to integrate models or new models into existing systems. What happens usually is on my machine works, you put it on another machine, it doesn't work anymore. So we know now the challenges, or at least I've shown you the challenges. So with Neuralyze, we want to make things easier for the whole process, to make things less complicated. So first, we have AI democratization. It is just a big and fancy word to just make AI accessible to everybody, so also to non-AI experts. So you don't need to be an expert in order to access such tools, right? Then you have integrated MLOps workflow. So I think it's needless to say, we are at MLCon, of course, MLOps need to be there. And we integrate that seamlessly. So we integrate in a seamless manner the standardized process for data training, deployment, and monitoring. And then you have also an intuitive user interface. So with clear dashboards, it allows the user basically to navigate all the process without any further complications. And then you have annotated data label management. So we also provide tools which makes the annotation faster. And then you have transparency and traceability. So going back to what I was saying earlier, we also provide the tools to track your model training and also to understand which model you have deployed, which one is performing good, which one is not. And then you have seamless integration, so to make easy the process of integrating new models into existing systems. So what is Neuralyze Desk? It is a no-code workflow, so you don't need to have programming knowledge. And you also have full ownership on your data, so you don't need cloud commitments. You have full control on your own data. And then you have, so for domain experts as well, so if you are a specialist in whatever domain, you are able to have the full control on your whole training process and deployment. And finally, fast time to value, which means basically that in a bunch of clicks, you already can have a working model within really a few steps. Right. So talking about computer vision, these are the challenges that you can tackle with Neuralyze. So I guess you already know classification, semantic segmentation, object detection. Do you know about anomaly detection? Yes? Okay. That's good. And yeah, OCR. So, and in the future, we will also have 3D classification, which mostly is to classify 3D objects instead of 2D images. So these are the tasks that you can tackle with Neuralyze. Then you have the annotation. And here is a quick look at how you can annotate images. So you have a complete control and on the annotation workflow. You can basically upload the images and then you can annotate them. This is an example of semantic segmentation. And you don't need to segment the whole thing. So for instance, this is a asphalt crack detection, where essentially the goal is to find crack in the asphalt with your model. But you just click the areas where the crack is, and then it will segment it for you. So this is what I was meaning with smart labeling. And then you have distribution visualization, which basically means when you have a dataset which is extremely large, so you have 1,000 of images, it gets quite difficult to know what you have labeled until now, how many samples you have. But with the distribution visualization, you have an insight of how the classes are distributed, so on and so forth. And then training. So this is the part that I prefer the most. And you can, as I said before, full control on the whole process. You have a lot of parameters. I mean, you have quite a few parameters because it gives you a lot of freedom to manage the whole thing. And we can start, for instance, with a setup. It tells you how many images for the training, how many for the validation. You can also do transfer learning. So you can start either from scratch or, for instance, fine-tune an existing model. Then you can also pick grayscale or RGB images and the size of the images. And another cool thing is the tiling. So in an industrial scenario, usually you have images that are really high resolution. So it can be also 3000 by 3000. And then I challenge you to feed a model 100 images with 3000, but it crashes. It gives you GPU error. So CUDA out of memory. But right. But with tiling, you can just split the image and then feed the tiles to the model, and then you don't lose any resolution. And this is also important. Then you can pick different architectures. So that is ResNet, but you have efficient net, you have DenseNet, MobileNet, and you can pick the architecture that better suits you. And decide the model complexity. And then you also have batch size, epochs. So you have quite some freedom with that. But I would say a crucial step is data augmentation. So whenever you have like a restricted data set, you can create more images with that augmentation, and there you can create different versions of the same image. And this improves model generalization. So after training, you have inference, because after training your model, you need to know whether it's performing well or not. And then for a different task, you have different metrics. So you have, for instance, F1 score, precision, recall, intersection over union. You can get even more metrics, but those are fine for now. And depending on those metrics, you can measure your model's performance. And you can also compare performance between models. So after that, let's say to summarize the whole concept or idea, what you do with Neuralyze Desk is you are developing a model. So you're working the training environment. You start with your data set, you annotate it, you train it, then you do it again. So you evaluate it and you do over and over again. When, let's say, the customer or you are happy with the results, you deploy it into production, so on a machine. And this is the whole cycle also about MLOps. So as I said before, you annotate, you train, and you evaluate, and then you have to do this over and over again. And this, with Neuralyze, is quite easy. And you don't need a lot of knowledge to do this. And this, I would say, is the whole summary about Neuralyze. Now, some application examples. I don't have any machinery to show you. It's just the, the software. But I will show you briefly what you can do. And I hope that I'm still on time, I guess. Okay, I don't have the connection. Right, I forgot to use the Wi-Fi. Is it free or you need the password? Because otherwise I will just leave it. Okay. Which one is it? This one. Uh, this one. Okay. Otherwise it's fine. Forgot the most important thing. It's not working. Okay. Well, I guess that was the end of it. But I had to set it up earlier. I would have. I will be the application. No, but it's kind of a pity. Maybe I can show it later. No? Yes? If we have time. I guess not. Okay. Then if you have questions about it, just feel free to ask. Yeah, that would be cool. Last chance. To join the room? What do you mean? Okay. Mm-hmm. Where is the hotspot? Can you still provide the hotspot? That would be cool. No? But okay, but I think it won't work. Yeah, I think it's easier with the hotspot. Okay.
Yeah, this one.
This one. iPhone. Yeah. Which one is it? C5G S43PG. 4 minutes. Okay, it's enough. Okay. Wee. All right. Thanks. You are the MVP. Okay, I have 4 minutes, so I will just go super quickly through it. Yes, let's way to go. So for instance, here is like the cam block inspection is just really a small metallic part that, I mean, in this case, we want to inspect and typically is used in furnitures, right? You have also the whole description of the project, but for now, we don't really care about it. So in the annotation tab, you can, in this case, there are already images, but the first step that would be you would need to do is, of course, to upload images. And then the cool thing about it is that you can also organize data by tags. So to not get lost in the limitless amount of data, you can group images by tags, and this is pretty useful. So for instance, the board crack, just so you have an insight with the images, we are just looking for scratches. Here in this case, data is already labeled, but I will also show you some examples, for instance, with the smart labeling. So of course, here the label is already present, but you can also pick the smart labeling. You can also set to auto. You can also add your own AI model to segment it automatically. But in this case, it's already provided. And the cool thing is that you can also pick between masks. So you click a point on the image, it provides you a mask, and then you can choose between 3 different versions. And in this case, okay, the first one is not good. The third one, maybe, yeah, this one works. And then it already segments it for you. So this was just an example. So this is for the annotation part. And once you are done with the annotation, so you have enough labels, you create your own data set. You split it into training, validation, and test, or training and validation, however you prefer. And then you go into the training. So this is the whole tab. So here I have already some models which have been trained. And you also have the training and accuracy curves on the right-hand side. And this allows you to track the whole process, and it's pretty convenient. I mean, usually training loss and accuracy are just indicators to know if your model is doing well or bad. It doesn't really say a lot about performance. And then once you are done with the training, you go to the inference. And for instance, we can pick some images in the validation just to have a show, just to show them to you. So you loaded the model data. And for instance, here they are already labeled, but if we take away the label and you perform the inference, it does it for you. And in this case, the model was trained, I think, on around 100 images. I think you can see it from here, from the training. So actually 280 and 51 for validation, which is not a lot. Yeah, and once you are done with the inference, because you also have, as I said before, the pixel accuracy, because we are talking about segmentation, and so the F1 score. So with these metrics, you are able to track your model, and then you know if it's performing correctly or not. And then in the end, you export it because you need in this case, we were working with the ONNX format, if you are familiar with that one, and then you can deploy it on the machine. I'm done. So thanks for the hotspot.
Thank you. Are there any questions from the audience? Yes.
Thank you for the talk. What was the most challenging part when building the tool?
Right. So I would say it was actually to understand how to organize the whole interface. We really cared about the usability of the tool. So it wasn't really easy to understand how to organize the whole cycle, because it has to be kind of intuitive for the user. And at the beginning, it wasn't really clear how to do that. And we just needed to use the tool and understand what is working, what is not really working. So then actually you go back to the user, you ask him, what is your preference? Do you like the way things are going? And we had a lot of different variations on how to organize the whole process. So I would say to organize the interface and probably also deployment. It was quite difficult and challenging. Because when you convert to ONNX, if you work with PyTorch, for instance, of TensorFlow, it doesn't matter which one of the two. But essentially, if it's a new model and you don't have the ONNX operators for it, it's quite difficult, because then you have to code them yourself. So what I want to say is that it's not that straightforward if the models are not consolidated enough. So they are new models. It's difficult to convert them to or deploy them in another format.
Yes.
Hi. Really cool tool. Are there any plans to like extend features in the tool so that we can better curate data sets so that we capture more broader variety of data?
Absolutely, yes. Actually, we are open to suggestions. If you have other ideas or something that you think might work even better, feel free to suggest, because it's like we are still on adding stuff into it. So as I said, if you have new ideas, of course, we will integrate as much as we can. So to make things also easier. There is, for instance, also for segmentation, what we are also looking into is, for instance, few shot learning or zero-shot learning for segmentation, where you just provide a couple of examples, and then the model annotates the data for you. And then you would just need to do like some supervision. So there is also some work going in that direction.
Yeah. So for example, if you want more variability of your data set, let's say you have like 10,000 scans, but you only have time or resources to annotate 1,000. You train a model on those 1,000, and then you run inference on the remaining 9,000. And then you TSNE plot the latent features of that.
Yeah, you
and
can.
It kind of tells you which areas you've not annotated in the 2D plot. So maybe that's another feature that you could add. It's something that other annotation tools also have.
Yeah, the idea is also to help the model annotate the data with you. So you train a first iteration of your model. When you see that the data is enough, it can annotate the other data for you. So you can use the inference results as annotation if that's what you meant.
It's more of a way to see which areas within the TSNE plot you've not annotated. So like out of distribution samples.
Okay.
But yeah, essentially the model kind of guides you. The model that you trained on 1,000 images, it guides you.
Yeah, looks like a good idea.
We have time for one more. If there is one?
How many pizzas left?
I think you were first by a hair, actually.
I'm curious to know how old is this tool and what is on your roadmap. So, for example, regarding training, do you plan to add features to train in a distributed manner on different servers, or do you abstract that from the user?
Well, so we are working on this tool, if I'm not mistaken, since 2017 or 2018. And as far as training is concerned, so to add features, the question is always how many are going to use that? Because if there is just one person, please add this feature. Yeah, we'll add it. Then nobody uses it. It's useless. But for instance, we were thinking about to automate. So I think it's called AutoML. Basically, you set up grid search, then you press a button, and then you just leave it, and then you will see which is the best performance. But in the end, what we also noticed is that it's not like a Kaggle competition where you need to get like 99.78% accuracy. You just need a model that works. And so the short question is yes, we can implement more features. The long question is we implement them if they make sense. So as an example for the grid search, it would just squeeze the performance to, I don't know, 0.something%. And it's more work that you have to do with the feature integration rather than the results that you get.
All right. I think there will also be the opportunity to ask more questions later on.